Oh no, he's not done. He just spent an hour and a half talking about sample prep. What on earth? And there's still more to this lab. Actually, yeah, if you went into the lab and you did the sample prep that we just did in the previous video, it would have taken you over an hour and a half to get everything that you needed before you even got started. So that particular piece of the lab experiment, that would have went probably all the way to 3-hour time block by the time that you gathered, by the time that you got everything situated, everything labeled, everything diluted, because it probably took me, honestly, a little longer than half the day in order to prep and get all of those samples loaded into the Headspace system. So, with that said, in this video, we're going to talk about the next portion of the lab experiment, and that is the instrument piece. So now that we have these samples in a Headspace file, what do we do with them? That's the thing. What do we do with them? I don't know. How are we going to analyze them? What's going to happen? How do I get the alcohol in the blood? How do I figure out if somebody's drunk because you gave a blood sample and it was my job to test to see if you were driving under the influence, so that way we could write you a ticket? Okay, so now we're going to have to focus on the other half, and that's the equipment part. And just a quick review, in the previous video, I showed you that equipment. And that equipment, we ended up with a picture, and it had everything included. And now it's going to be our job to break that down and talk about this in a little bit more detail. So the first thing that we want to do is show you the hydrogen generator that is required for the machine. And here it is. All right, so we talked about this in the previous video very briefly, and here we're going to talk about it in a little bit more detail. So the hydrogen generator, the sole purpose of the hydrogen generator is to go through and get this instrument to produce good OH number 2. Oh, look at there. It's all crooked and nasty. And that's because my pen stopped working. Okay, here, let me see if I fixed it. Aha, look, yay! All right, so H2. H2 is the hydrogen gas, and the hydrogen gas is going to be needed not for the Headspace system, folks. This is not for the Headspace at all. This is for the FID, and the FID is the detector of the machine. That is the eyeball that sees everything coming through this chromographic instrument, or chromatograph is what we call that. And the purpose of the hydrogen generator is to produce hydrogen, because hydrogen gas can go boom, pew, and away goes the natural science building that we're in. So we don't want that to happen, and therefore we don't like the idea of keeping hydrogen tanks in our laboratory at all times. We do have the backup hydrogen just in case, but we rarely use it, and we set it to the side and we secure it, but it's there if needed. We just don't like to open up the gas flow, because there could be a leak, and that leak could fill up the entire room, and then pow! I don't have a job anymore, because there's no building for me to teach in anymore. So the hydrogen generator allows us to go through and generate this particular type of gas as needed. That is the purpose of the hydrogen generator. So the hydrogen generator really needs air, and we have a air tank. It's over here to the left. You see those in the green tanks. It's over there to the left. All right, so that is going to be our and those air tanks that you see over on the left, it is high purity grade air. So this is not just air that's in the room flying around that you're breathing in. This is actually a filtered air supply that is 99.999% pure. So not exactly 100, but pretty close. All right, so this is going to require air and it's also going to require a little bit of water. And that's how this hydrogen generator does its job. So, back in the general chemistry days, you learned about a reaction that was water, and water can decompose. And the only thing that you need is a little bit of current, DC current, or whatever you want to call it. You just need some electricity. And it's going to break it down into H2 and O2 gas. Now, there's two hydrogens to the left and two hydrogens on the right. And there's one oxygen on the left and there's two oxygens on the right. So this is not balanced. So I can put a 2 here. So that way we get 2 oxygens and 2 oxygens. But by doing that, we get 2 times 2, which is 4 hydrogens. And over here, we're going to have to put a 2 in front. And that will give us 4 hydrogens there. So this is going to require water, and water is supplied by you. So you're going to have to go get the water and fill it into this hydrogen generator. That's how this thing works. Over here, I'm going to change my color. Over here in this left-hand meter, this is like a gas tank for your vehicle. This is how full the hydrogen generator is. And right now, that hydrogen generator is about half full. So it will be enough in order to get me through this analysis. But at some point in time, I probably would want to actually fill this up or drain out what's in there and fill it up with fresh deionized water. This is not tap water, and preferably it needs to be distilled and deionized, not just deionized, but we don't have an in-house distillery. So, in other words, we settle with deionized water, it's clean enough, we'll be fine, and that's what we'll use for this analysis. When I start this hydrogen generator, the power switch is on the back. So when I begin it, there is a countdown, and you will see that on the screen here in front. And that countdown actually starts at 60 minutes. And it will take 1 hour for the electric current to zap through and generate enough hydrogen and, as a byproduct, oxygen, but enough hydrogen in order to operate this instrument. Once you give it that 60-minute wait period, this instrument beep, 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 it beeps, and it lets you know that it's happy and it's ready, and it has enough hydrogen gas that will at least meet your immediate need. Now, it will generate more as needed, but in the beginning, when you start it up, you've got to wait for this hydrogen generator to do its job. So that means that if I did not do this for you and you had to do it on your own, you would have to go into the lab 1 hour before you're ready to run things and turn this instrument on, so that way the hydrogen can build up on the inside so that instrument will have enough to eat and operate. So that's what you're seeing on the screen here. This screen is actually down here at the very bottom. So the power's not yet on in the picture that shows you the actual generator. But when I do turn the power on, this automatically just starts up, and it knows that you want it to generate hydrogen gas, and it just automatically just takes over. But you got to give it 60 minutes in order for it to do its job. So there's the hydrogen generator. Again, on the back side, it is an air supply that goes into the back, and it uses that to kind of help the instrument push the hydrogen and everything else into the GC, which is where it will eventually go. Next up, the other part of an instrument is our GC system, and that's what you're seeing here. So this is our GC, or our gas chromatograph. That is what this instrument is called, chromatograph, GC. There's different forms of GC, different instrumentation manufacturers of GC that's out there. Shimatsu is the brand that we're using today with this blood alcohol lab experiment. It is not the only GC that we have in our lab, and it's not the only manufacturer of GC that we have in a lab, but I just decided to use this one because it's a little newer and it's a little easier to use as far as the headspace system goes. And that's really kind of why we're doing today's lab. lab. So I felt that this was going to be the path of least resistance for me. So Shimadzu is the instrumentation manufacturer, and this is the GC portion of the instrument. Yet again, there's a power button on the back of this thing, and there is a big black screen that's right now on the front right-hand side. I've just circled that, and when I turn the power on, the instrument's going to go beep, 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 and then it shows me this screen that eventually appears in the display. That screen is a way that we can control the instrument using all the little telephone buttons down here at the very bottom. But we don't do that. We use a computer and we use software in order to operate that instrument. It's just, that's the way it's done most of the time in real life, and that's what we're going to be taking advantage of. The software can do what it needs to do, but if you did not have the software or computer and you needed to do manual things at the instrument, you can do that through that display and through the keypad functions. So that is why it's there. So for instance, you see start GC, set the start flow, set the start temperature, set the detector, cleanup, standby, start the GC, file, cleanup, all these buttons. And that's just the little top of the top, the little cherry on top of your nice little GC sundae. That's what this is. So there's screens involved in screens, involved in screens, and it's just a pain. But you can do it if you want to. But we use the software and computer system instead. So this is our GC system. Again, Shimadzu is the manufacturer. And we also have an Agilent. So now the Agilent is not what we're using today, but we also have a Agilent headspace system. And the one that we have in our laboratory was actually donated by a local company, and that company was Quality Control Laboratories. So thank you again for your donation. We have used it in the past. We're just not using it today. All right. So this is actually a door. You can see a handle over here to the left-hand side, and that handle I'm going to put my hand in and open up the door, and when I do that, that door opens, and on the inside, this is an oven. O-V-E-N, oven. This is where I'm going to bake my cake. Well, actually, no, it's where I'm going to bake the column. And that's actually what it's called. But it's also where separation begins to take place. So the oven is actually a heated chamber. And I'm going to draw a triangle here. And that triangle represents heat. And this instrument, when it turns on, when it begins to run, this will be a heated area of the machine. And we can heat it really hot, and we can heat it maybe just at room temperature or slightly above. We get to control that. That's us as a user, and that will all change depending on what we're trying to analyze. So for our blood alcohol concentration lab, it's going to tell us a temperature setting that we need to be using for what they call our column. So we have went into the software and we have inputted those values in because we've got to follow those standard operating procedures. So we enter them in and we just double check them and make sure they look good. And if they look good, then ching-ching, we're off to the races, folks. We can start running samples. Well, the column piece is actually, if I can, do this a little bit better. I'm not sure if I can or not, but we'll see. So if I can, oh, that's not going to work. Look at that. Nope. All right. So right here is the column that's inside of the GC system. That is where our sample is going to eventually go to. So right up here at the very top of the GC system, the sample is eventually going to go into that entry point. And if you feed that line down, you're going to see that that will lead itself down into this circle thing that's inside of what, again, we call the oven. That is where separation takes place. That is where our alcohols begin to separate from each other. And we have to have separation or we can't really tell how much ethanol is there because it is surrounded by all the other stuff that might come along with it. So I need ethanol on its own in order for me to do the analysis, and that requires the separation. That is the point of the GC system. It is there to separate. And if it cannot separate, folks, We can't really do any kind of reporting at all on these blood samples that we have been handed over in order to analyze. All right, so if I zoom in a little bit closer, here is the oven door that you can see maybe that column on the inside a little bit more. This column is made of glass, believe it or not, and it is very thin and it is very narrow. So how narrow's narrow, Tracy? Okay, well, narrow means about the size of a hair strand. One little hair follicle. That is how wide this column is on the inside. So that's the tunnel that all of these components will go into, and they will race through this tunnel and out the other end. And when I go out the other end, it's going to go whoop up in there, and that's where the detector is. That's where the eyeballs are of the machine. So very, very thin, super narrow, but at the same time, very long. So if I go a little bit closer in and I take a picture of the tag on the column, this is what you're going to see. It says Shimatsu because we ordered it directly from them. The phase, which is the material that the inside of the tunnel is made out of, is SHBAC +1, whatever that means. Who cares? So you might be asked about it. The dimensions are 30 meters. So yeah, 30 meters long. 1 meter is the floor to your waist times 30. And the ID is 0.32 micrometers. And the serial number is 1646448. And we can go to 240 to 260 max with that column. So that's where I'm going to stop this video. And the next one we're going to pick up from here and we're going to continue on. And we're going to go back and talk about the gas tanks.